I said equivalent, you would think fraction, because you know that fractions can have equivalent answers. 1/2 is equal to 5/10. Today we're talking about equivalent division problems, because if you remember, every fraction is a division problem. So, let's get started. If I were to ask you the answer to these division problems, this says, how many thousands go into 3,000? Some of you would immediately know 3. Some of you may change the problem to make it easier. If you'll look at this place value chart, this is still a division problem. 3,000 divided by 1,000. And if I move this on my place value chart, I can change the division problem. Now it says 300.0 divided by 100.0. Now it says 30 divided by 10. And now it says 3 divided by 1. So, because I can slide these up and down the division bar, or the place value chart, I could say that this problem, how many thousands are in 3,000, is the same as how many hundreds are in 300, or how many tens are in 30, or how many ones are in 3. The answer to all of these is 3. So what if I said how many 50s are in 400? Well, 50 into 400. How many 50s are in 400? That problem looks like this on our place value chart. The 4 is in the hundreds place, and the 5 is in the tens place. When I slide it, my new problem says how many 5s are in 40. So this says how many 5s are in 40, and the answer is 8. Because the answer is 8 on this one, it's 8 on this one. Well, what if we slide it the other way? Does it still work? What if I did, how many 6s are in 9? So this says how many 6s are in 9. The same amount as 60s that are in 90. The same amount of 600s that are in 900s. So this is the same as this, which is the same as this. 4 into 15. How many 4s are in 15? The same amount of 40s that are in 150, and the same amount of 400s that are in 1,500. So, this tells us that we can slide the numbers either direction on the place value chart and get equivalent numbers. Why would we want to do this? I would doubt very many people think these are easier than these. Well, if I ask you the question, how many sets of 500s are in 6/10? In order to write this on our place value chart and have our place value chart help us, we would write this as a fraction. So we would write 6/10 divided by 5/100. Now it's a matter of putting my 6 in the tenths place divided by the 5 in the hundredths place. And I want to slide it until there are no decimals on the bottom, because I want to be asked about whole numbers. So it has to stay in this position. We have to move it the same amount of times. So how many sets of 500s are in 6/10? the same amount of 5/10 that are in 6. The same amount of 5s that are in 60. So how many 5s are in 60? The answer is 12. So the answer to this is 12. 12 sets of this would make 6 of our rods. Let's try some more. We're going to take the original problem and we're going to rewrite it as a fraction that would be on our place value chart. So, the dividend is in the den. The dividend comes first. 6/10 divided by 3/10, which means that I would need the 6 and I would need 3. And they would both be in the tenths place. And I would slide them until they were no longer behind the decimal. So now this says 6 divided by 3, which is my equivalent problem. 6 divided by 3. The answer is 2. This answer is always the same to this problem. This is just 2. That means that 2 sets of 3/10 fit in 6/10. Let's look at this with place value blocks. This question says, how many of these fit in this? Well, there are 2 groups of 3/10 in 6/10. In order to figure that out, we moved the decimal in the divisor the same amount of times as in the dividend. The divisor is where we don't want a decimal. So, let's look at the next one. Rewrite this as a fraction so you can slide it. 4.8 divided by 1.2. I am going to slide 4.8 on the place value chart the same amount of times. So I'm going to slide it once here, which means I'm going to slide it once here. My new problem is 48 divided by 12. 48 divided by 12 is 4. How many sets of 1 and 2/10 fit in 4 and 8/10? 4. No decimal in the original answer, even though there are decimals in the original problem. Let's try this one. 200ths. How many sets of 200ths would it take to fill 4 flats? 1, 2, 1, 2. Let's look at it on the place value chart. 4 is in the ones place, and 200ths is here. And I want to move it until the 2 is a whole number. So I move it once, I move it twice. And now I have a problem that says 400 divided by 2. 4 divided by 200ths is the same as 400 divided by 2. And 400 divided by 2 is 200. So the answer to how many sets of 200ths are in 4, or the answer to 4 divided by 200ths is 200. Remember, the answer to your equivalent problem is always equal to the answer in your original problem. Now let's try it in word form. How many groups of 9/10 are in 3? How many groups of 9/10 are in 3? What is 3 divided by 9/10? Because there is a decimal in the divisor, I need to move it until there's not. So because I moved it once here, I'm going to move it once here. My new problem, my equivalent problem, is 30 divided by 9. I would solve 30 divided by 9. Then I would get a repeating decimal. The repeating decimal that I get here is the answer that goes on the original problem. How many groups of 5/10 are in 5? How many groups of 5/10 are in 5? The same amount of 5s that are in 50. How many sets that look like this would it take to make 5 flats? The answer is 10. So 5/10 into 5 is 10. Notice I don't change anything with the answer, even though I've changed the problem, because the problems are equivalent, the answers are equivalent. One more. How many groups of 1 6/10 are in 64 hundredths? Move it once here and once here. So now I'm asked the same amount of 16s that are in 6.4. And because I'm asking how many sets of 16 are in 6.4, the answer has to be less than 1. So 4/10 of a set of 16 is in 66.4. Now, it's your turn to show what you know. Rewrite each problem as an equivalent problem by moving the decimal in the divisor. Then, solve it. The answer that you get is the answer that you write. All right, let's see how you did. How many sets of 5/10 are in 500ths? Because the decimal has 1 behind it, we're going to move it once. Because we moved it once, we're going to move it once. We're not going to try to solve it in this position. We're going to rewrite the problem. 5 into 5/10. The decimal comes straight up. The answer is 1/10. So the answer over here has to be 1/10. The problems are equivalent. The answers are the same. 1.3 into 26, or 26 divided by 1.3. Or how many sets of 1.3 does it take to make 26? So, because there is a decimal here, we have to move it once. Because there is no decimal here, we use the understood decimal, that's at the end of every whole number. And our new problem is 13 into 260. And the answer is 20. So how many sets of 1.3 are in 26? 20. The problems are equivalent, the answers are the same. Move this once, move this once. My new problem is 6 divided by 1. The answer is 6. How many sets of 400ths are in 8/10? Because I have to move this twice, I have to move this twice. So it would be 4 into 80. The answer would be 20. Because this answer is 20, this answer is 20. Problems are equivalent, answers are the same. How many sets of 1.5 are in 3? How many sets of 1 5/10 are in 3? Move this once, move this once. My new problem is 15 into 30, which is 2. So how many sets of 1 1/2 are in 3? 2 sets of 1 1/2 are in 3.